Yeah, I mean, fundamentally, there's four fundamental forces in physics: electromagnetism, gravity, the strong force, and the weak force, right? And all of our manufacturing processes and everything that we produce here on Earth is predicated on those four forces. And you can't really change those. You can't turn those off. They're all fundamentally, fixed, and everything's designed around that. And we are basically a platform that allows you to turn one of those forces off. And as you can imagine, people have done some level of experimentation about what's possible with that, but almost certainly we have nowhere near to even scratch the surface of what is possible with the various materials that you could produce that. However, you can't just launch a platform. You have to provide value to an end customer. The analogy that I always like to provide is like, the iPhone did not launch with the App Store. It launched with 15 apps that were extremely well developed, that were beautifully designed, and that consumers truly loved. And then a couple generations in, they launched the App Store once they had proven the value of the platform. And so that's what Varda's focus on today is like, yes, I think there's going to be a wide array of materials that are produced, but we're focused on one or two initial applications that are based off of work on the ISS that is the most scientifically de-risked and has the simplest sort of thermo and mechanical hardware environment so that we can produce that in a way that doesn't require 6 degrees of freedom, doesn't require crazy robot arms, can be done with reasonable unit economics, and then most importantly, actually has value to customers down here on Earth that could potentially actually make the unit economics of a space factory possible. And so when we're considering that trade study of all of the materials that have ever been researched, one of the most important high-level ones is relative to any process that you have on Earth for producing this or relative to other materials that you can compete against, how much value does this provide to the end customer? And there's a lot of materials that I think are very fascinating. So, for example, people have shown work around improving the capabilities of semiconductor wafers. But the problem is, like, we actually make pretty damn good wafers down here on Earth, and the ones we can make in microgravity, at least so far, they're at the high end of the spectrum, but they're just the equivalent of the high end of the spectrum down here. And, like, yes, it's more consistent, and the yield is better, but man, competing on yield alone is really tough. Versus there are other things like pharmaceuticals where it's actually taking a drug that was previously, toxic and failed phase 2 clinical trials to something that can actually get all the way through and actually can be absorbed by the human body and is effective. That effectively has, like, billions and billions of value if that is allowing a drug to go to market, right? And so it's making sure to run that study on how much value does producing this material in microgravity provide your end customer relative to any other alternative, obviously, that they have, given that, like, space factors are quite expensive. And so, yeah, at some point over time, I would like Varda to transition to being a space factory as a platform, and we're more of a contract manufacturer that people come to us and say, hey, I've got this material, I'd like to experiment with it in microgravity. I think there'll be some value in it. But until then, we're kind of a pharmaceutical company and a semiconductor company and a fiber optic company and a human organ company and proving the value of those. And then one day we'll be the platform.
And maybe another